Welcome back, Math 30-2s to the second lesson. I'm going to try for you guys in terms of walking you through and explaining some examples in the workbook. And this is actually the last lesson in exponential and log functions before we move on to the next chapter. So today what we're going to do is take a look at how we model data using exponential and log functions. And again, it's really just a new twist on something that we've done before in a previous chapter. So the basic idea in today's lesson is that we're going to be doing a regression analysis, and the types of graphs that we're going to see produced by the data are either going to be an exponential or a log function. Again, it's just going to be up to us to determine and look at the shape of the graph and then pick the type of regression that best matches those points. So when we take a look at the first question, again, I'll read through it with you and then we'll take a look at the data presented, plot it, and then discuss from there. So it says, Simone, a medical research scientist, is investigating a new bacteria culture which could help strengthen a person's immune system. She isolates 50 cells and records the growth and the number of cells over a period of 5 hours. Her results are shown in the table below. Part A says plot the data on the grid to investigate the type of growth pattern. So you will see here that what they have done is given us a table of values, okay, and they've been really nice to us again, and they are telling you that the first column or row of data there, okay, your X values there, okay, are the number of hours, and the second set of data there, the Y values, are number of bacteria. So from that, again, we should know what is going to go on the independent-dependent axis, or the X and the Y axis. As well, when we get to this point in the next couple of questions, you will now know that when I enter these values into my lists, that this will be list 1 and this would be list 2. Okay, so basically plotting the data, the first point, okay, comes from the first X and Y values, so 0, 50 is the first point that I put on the graph, okay, which will be, oops, not there, I apologize, right there, okay, I can see that the y-axis is going up by 50. The next point will be 1, 75, then 2 and 112, 3, 169, so just past 150 here, 4 and 253, so just past the 250 mark, 5 and 380, okay, so just about 400, okay, and then there are all the data points that we have plotted from the table of values. Now, based on the shape that we have created there, it says from the list below, select the best alternative for the type of growth pattern exhibited by the data. So when we take a look at that, okay, from what we know, okay, that is most likely going to be exponential, right? Linear we know is a straight line, quadratic produces a parabola, and logarithmic, okay, is the inverse of the exponential function. So this is going to be exponential. Moving on. So like I mentioned at the beginning of the lesson, okay, what we're basically going to discuss today and review is regression, okay, which we can see right here in that bolded word. And basically we're going to apply that to exponential functions, which take on this form, okay, and log equations, which we studied last lesson. The regression features of the graphing calculator will be used in this course to determine the equation of the best possible exponential function. And again, we went through those steps in the previous chapter. They do review them in the next coming couple of pages here coming up. I will skim through them, but they're there for you to review again as we work through some of the examples. And then the gentleman down here at the bottom with the fake stop sign again saying, note that the graphing calculator can only be used to determine the best possible linear, quadratic, exponential, or trig function depending on the pattern exhibited by the data points, meaning it's basically a line of best fit for the shape that we are creating from the data. Okay. Turning the page. Now, like I had mentioned just briefly a minute or so ago, the next couple of pages are just a review of all of the calculator keystrokes and the process that we need to remember when we are entering data into our calculators into list 1 and into list 2 as we try and determine a line of best fit, okay, when we do an analysis here. Okay, so if you have questions at any point with any of the calculator keystrokes, again, feel free to email me and I can help you with those. But we go through these basically step by step as we deal with the one example that we're really going to take a look at today. Okay, so if we turn to page 228, that's what we're going to read through and work through together. In class example 4 from the previous lesson, we discussed carbon dating. The percentage of carbon-14 remaining was expressed as an exponential function of the age of the organic remains. Since a log function is the inverse of an exponential function, okay, and again, that's, again, a key point. So if you want to highlight that, that's probably not a bad idea. We've highlighted that and discussed that in a couple of other sections, but again, always good to review it and remember that moving forward. It is possible to switch the variables and write the age as a log function of the percentage of carbon-14. So they switch the x's and the y's. Okay, now these are my x values this time, the carbon-14 percentage, and the age in years are the y's. So now when I go, this will be list 1, this will be list 2 in my calculator. So part A says, create a scatter plot using a graphing calculator to confirm that a log function is an appropriate model for the data. So at this point, you would go back, if you did not remember, and you would have to clear all your previous lists, enter all of your x values here, okay, into list 1, and then enter all of your y values here into list 2. Okay. Once we do that, we then have to basically take a look at the data points that we create, and what you will see, okay, is that those plotted points, okay, create some kind of shape that looks similar, okay, to that moving down. Okay, and from that, in part B now, they say use the natural logarithm regression feature on your calculator, which when they are talking about the natural log regression feature on your calculator, okay, this is what we are searching for, okay, in that list. And then they give us the nice, very straightforward instructions as to how to write out the equation. We're looking for the A and the B parameters, and they want us to use integer values there. So again, remember, an integer is a positive or negative whole number. So as I go through those steps, okay, and I want to basically enter that equation, okay, and I'll have you do those steps on your own, you will come up with an equation that looks like this. Y is equal to 38,067, and then it will be minus, okay, because we have a negative value for B, 8,266 natural log of x. Okay, so that is the equation that is created for us using the calculator keystrokes when we do the natural log regression. Part C says, on the graphing calculator, display the graph of the regression equation in B over the scatter plot in A. So what we want to do from there, or what they're asking us to do from there then, is go back to the plotted points, okay, that we have plotted from list 1 and list 2, which is up here, and have that line of best fit basically be graphed through those points. So when I do that, you will see your calculator basically goes like this and draws a line, okay, through all of those points, okay. So that's what we're taking a look at. Now from there, okay, now that we have the graph on our calculator, we are now able to answer the following questions. Okay, we can't answer these following questions until we have graphed that equation through the plotted points. Okay, and that's what it basically says in D here. Use the graph in C now to answer the following questions. So part 1 is a bone fragment with the carved image of a mammoth was discovered in the southern U.S. state of Florida in June 2011. If the carbon dating test indicated that approximately 20.3% of carbon-14 was left, estimate the age of the bone fragment to the nearest 1,000 years. Okay, so a couple of things here. They have given me 20.3% of carbon-14 was left. Now, in today's example, we've switched the x and y values from last day, so that means they have given me an x value equal to 20.3. And remember, they can only ask me one of two things here, or ask you guys one of two things here. They're going to give you the x value and expect you to find the y, or they will give you the y value and they're expecting you to find the x. So obviously in this question, they've given me the x. They are looking for the y value. So again, on my calculator, I can simply enter 20.3 once I push trace on my calculator. Okay, and what will happen is the y value that is calculated for me or from that graph and the equation on your calculator is 13,182 decimal approximately 071, okay, which to the nearest 1,000 years is 13,000 years, okay? So there is our answer for this question, okay? So try that either along with me or after you're done listening to me, try that and make sure you can get that as an answer. In part 2, it says, if the skeleton of a bison is about 10,000 years old, what percentage this time? So now they're looking for the percentage, which is, in this case, we know the x's, to the nearest whole number. Okay, so again, picking out all the important keywords here that tell me how to answer the question correctly. What whole number of carbon-14 should the paleontologist find remaining in the bones that were found? So this time, again, just like we did last day, I'm going to graph a second function, okay, under y2, which is equal to 10,000, okay? So they are looking for the x here. So I want to, once that 10,000 is basically graphed on my grid, okay, I'm going to have this. I'm going to have the log function, okay, that comes through this, the natural log, and then I will have some kind of constant that is graphed through here, okay, at 10,000. Okay, I'm obviously looking to see where those two graphs meet right there. So they are going to intersect, okay, just like we did last day. They're going to intersect, okay, at an x value which is equal to 29.83, okay, etc. So they want this to the nearest whole number, okay, so which will be rounded to the nearest whole number, 30%. Okay, and there's your answer. Last part says, compare your answers with class example 4 from the previous lesson. Okay, what do you notice from there? Well, the answers are exactly the same. So again, really short lesson today. Basically, the only thing that's new is that we did a regression analysis, but we are now using natural logs. Sometimes you'll do an equation that has to do with an exponential. You just pick the right selection from the list and then go from there. The calculator steps are always the same. Again, remember that they are given to you in a previous chapter, also in this lesson today, but heading into the diploma or a chapter exam, those calculator keystrokes you will have to know if you want to answer the question graphically. All right, look forward to any of your questions, and I'll see you next day with another lesson. Thanks, guys.